Welcome to this explainer. If you step outside right now, pick up a pine cone, or just look closely at the center of a sunflower, you are going to find a quiet, persistent pattern waiting for you. If you count the spirals going one way and then the other, you'll almost certainly land on numbers like 8 and 13, or maybe 34 and 55. Now, for centuries, people have taken those exact numbers and asked a pretty profound question. Is there some kind of secret code to the universe? I mean, we've all been sold this pervasive myth, right? The idea that a single magical mathematical sequence governs literally everything, from the spirals of galaxies to seashells all the way down to the proportions of human beauty. But today, we're going to take that claim apart piece by piece. Section 1, the Cosmic Code Myth. Let's see if it's fact or fiction. So, you've probably heard of the Fibonacci sequence before. It goes 1, 1, 2, 3, 5, 8, 13, and so on. Every number is simply the sum of the two before it. It's a beautifully simple pattern, and a lot of folks claim it's nature's hidden fingerprint. But here's the wild part. This sequence isn't some cosmic decree handed down from the heavens. It actually has a very clear human paper trail. Way back around 200 BC, Indian scholars like Pingala were using it just to count the rhythms in Sanskrit poetry. Fast forward to 1202 AD, and Leonardo of Pisa, the guy we later nicknamed Fibonacci, used it in an arithmetic book for merchants. It was literally just an absurd math puzzle about breeding rabbits. It wasn't even until around 1600 that the astronomer Johannes Kepler linked it to geometry. So right off the bat, it started as a human tool for poetry and commerce, not a fundamental law of the cosmos. Moving on to Section 2, the most stubborn number and how it absolutely refuses to repeat. To really understand what the universe is actually doing here, we have to look past the neat, whole numbers of the Fibonacci sequence and introduce the true hero of this explainer. It's a number that just completely refuses to repeat or be pinned down. Take a look at this. 1.6180339, and it just stretches out infinitely. This is the golden ratio, also known as phi. If you take the Fibonacci sequence and divide each number by the one right before it, so 13 divided by 8 or 55 divided by 34, your answers will creep infinitely closer to this exact, messy, irrational value. But they never quite land on it. And that right there brilliantly illustrates why phi is so incredibly special. If you write it out mathematically as a continued fraction, it is made entirely of ones. Just ones. Now, in math, having a big number in the bottom of a fraction makes it really easy to approximate. But because phi is built entirely out of the smallest whole number, it is literally the hardest number in existence to approximate with a simple fraction. It embodies pure mathematical stubbornness and a total absolute resistance to repetition. Let's jump into Section 3, the sunflower's secret, and take a look at nature's packing strategy. We're heading back to the humble garden to see where this incredible mathematical stubbornness actually becomes a lifesaver in the physical world. Imagine you're a plant, okay? You're trying to pack seeds into a flower head. Well, simple fractions are an absolute disaster for you. Think about it. If you place a new seed every 1/3 of a turn, they're going to quickly stack up into 3 super crowded spokes, leaving massive amounts of wasted empty space between them. A quarter turn gives you 4 spokes, same problem. Anytime a growing plant uses a simple fraction, it completely fails to pack its seeds efficiently. So to avoid those wasteful spokes, the plant needs an angle that never ever lines up with a simple fraction. What it needs is the golden angle, which is roughly 137.5 degrees. This specific turn is derived directly from phi, the golden ratio. By turning exactly this much for every single new seed, the plant guarantees that new growth is never going to line up into those wasteful, overlapping spokes. Now you might be wondering, how does a completely brainless flower compute the most irrational number in mathematics? Well, it doesn't. It's just chemistry. There's a plant hormone called auxin that gathers right at the growing tip. A new seed bump forms there, and as it grows, it drains the auxin from the surrounding tissue. Because of that, the very next bump has literally no choice but to form in the spot furthest away from the ones already there. The plant is simply running a physical game of mutual avoidance, and the natural, mathematical result of that avoidance means perfectly hitting the golden angle every single time. Section 4, demolishing fake magic with the ruler test. Okay, now that we know where the golden ratio is genuinely, verifiably real, it is time to bring a metaphorical ruler to all those grandiose, magical examples we've been sold for years. There is a huge, stark contrast between verifiable biology, like the growing tips of plants and sunflower seeds, and the manufactured myths. The Nautilus shell, the Parthenon, human faces, spiral galaxies. Listen, when we actually take the time to measure these things, the idea of a magical cosmic code completely falls apart under scrutiny. Let's run the ruler test right now. The Nautilus shell? Yeah, it's a logarithmic spiral, sure, but it grows by a factor of about 1.33 per quarter turn, not 1.618. What about the Parthenon? People just draw arbitrary rectangles over photos of it, completely ignoring the missing structural pieces that just do not fit the ratio. And Da Vinci's Vitruvian Man? It's explicitly built on simple whole number proportions drawn from Roman architecture, not phi. Honestly, the famous golden spiral is usually just a hopeful overlay that people creatively twist to fit their narrative. So why do we think we see it everywhere? It really just boils down to one word: apophenia. We all do this, by the way. Our human brains actually evolved to be incredible pattern-finding machines. We desperately want beauty and the universe to have a simple, universal formula. And that leads to massive confirmation bias. We count the handful of hits where a ratio happens to be somewhere near 1.6, we completely ignore the 90 messes, and we project a pattern onto the world simply because it makes us feel like we've decoded a grand mystery. Which brings us to section 5. Rings, crystals, and cosmos, the real math in the universe. Now don't worry, I am not here just to ruin the magic for you. We are going to leave the garden entirely now and look at where the mathematics of not repeating genuinely dictates the universe, but on a massive cosmic scale. To grasp this, we need to talk about resonance. In orbital mechanics, if two bodies sync up in a simple ratio, let's say circling a planet exactly twice for every one time a neighboring moon does, they are going to meet at the exact same spot over and over. Those gentle, repeated gravitational pushes accumulate into a massive, destructive force, which will eventually fling objects completely out of orbit. So out in space, simple, repeating whole number fractions are downright deadly. And this brilliantly illustrates exactly how gravity shapes our solar system. Have you ever seen the Cassini division? It's that massive dark gap in Saturn's rings. It was carved completely empty by a 2-to-1 resonance with the moon Mimas. Or the Kirkwood gaps in the asteroid belt. These are totally empty zones where asteroids were just flung out by Jupiter's rhythmic tugs. So what is the absolute safest orbit you can have? It's the one furthest away from those simple fractions. It's an orbit naturally governed by the most irrational, stubborn number out there, phi. We even see this happening all the way down at the quantum scale. Back in the 1980s, a materials scientist named Dan Schexman discovered quasicrystals. These are forms of solid matter that have perfect structural order, but they never, ever repeat. He actually won a Nobel Prize for this. Atoms are literally freezing into golden ratio geometries. Why? Because it is the most efficient way to maintain order while completely avoiding periodic repetition. It is the exact same problem the sunflower is solving, just handled by atoms. So what's the big takeaway from this explainer? The universe doesn't follow a magical, mystical cosmic code. Instead, it just keeps running headfirst into the exact same optimization problem: how to avoid repeating and piling up. Whether it's seeds pecking tightly into a flower head, rocks trying to survive a planetary orbit, or atoms freezing into a crystal, mathematics just keeps handing the universe the exact same stubborn answer: phi. It's an inevitable, practical solution for efficiency and survival. Which leaves us with this final thought. We aren't the intended readers of some mystical cosmic text. The universe was arranging its seeds and orbits using this math billions of years before we were even here to notice it. But if the universe isn't leaving little messages for us, isn't it actually so much more profound that we figured out the raw logic of its physics anyway? We can stand in a garden, hold a simple pine cone, and see the exact same shadow of the mathematics that holds together the sprawling rings of Saturn. And to me, that is far more beautiful than any secret code.